this diagonal AC. That's it. Right? So construction is join AC. Okay. So first of all, let us write what is a rectangle so that we know what exactly we have to do. So a rectangle is a parallelogram. First thing, with one angle, -90°, right? So basically the first step here will be to prove that PQRS is a parallelogram, right? And the second step here will be to prove one angle is 90, right? So this is for your understanding I'm writing. All right. So one by one, like if I have you written this much, Jaslyn? Okay, so if I make a column and do simultaneously. So first of all, I'm taking this triangle. In triangle ABC, can you see that? ABC. And then the upper triangle I'm taking, which is ADC, right? Okay, so in ABC, now it's given that P is the midpoint of AB, right? And Q is the midpoint of BC. So we can use midpoint theorem, right, Jaslyn? So what does it say? That if P and Q are midpoint, so that means PQ will be parallel to AC, right? And PQ is equal to half of AC. So this is midpoint theorem. You can call it your equation number 1. Similarly, in the upper triangle, now you have S is the midpoint of AD and R is the midpoint of CD, right? So we can use midpoint theorem again. Now I can say that SR is parallel to AC and also SR is half of AC. So this is midpoint theorem, result number 2. Jaslyn, please unmute yourself. Okay, I can't hear you. Anyway, if you can hear me, then it's fine. Actually, this way I don't, understand whether you are able to hear me or not. So that is why I keep on asking.
Can you hear?
Yes, I can hear. So
Yeah,
can
very
you?
clearly.
Okay, fine. Right. So you have got result number 1 and 2, right? Now, if you look at it carefully, so see, PQ is also parallel to AC, right? And SR is also parallel to AC. Can you see that? So it implies like if we combine the two results, so from 1 and 2. So now we can say, now both the lines are parallel to the same line. So we can say that PQ is parallel to SR, right? Okay. Now PQ is also half of AC. SR is also
Yes.
half of AC. So we can also say that PQ is equal to SR. So two things I have got, right?
Yes.
Now you look at the figure again, PQ and SR. So now this side is actually equal to this side and also they are parallel to each other, right? So we have a theorem that if only one pair of opposite side is equal and parallel, so it's a parallelogram. Remember?
Yes, ma'am.
Okay, so now we can use that theorem and say that it's a parallelogram. So now one pair of opposite sides is parallel and equal. So two things, parallel and equal, we have got. So we can say, therefore, PQRS is a parallelogram. So at least first step we have finished. Right? Okay, so I'm drawing the figure again so that you can see it. Okay. Now what we have to do is some writing. Now we prove PQRS is a rectangle. So parallelogram can be anything. It can be a square, it can be a rectangle, it can be a rhombus. So now we have to show that this parallelogram is a rectangle, right? Okay. Mm. Now see, ABCD is a rhombus which is given, right? ABCD is a rhombus. So therefore, now rhombus means all the sides are equal. So we can say AB is equal to BC. This is given to us that it is a rhombus, right? AB is equal to BC. That means half of AB is equal to half of BC. Both side you multiply by half. Now what is half of AB? So I'm taking this PB, right? So PB is equal to BQ. Is that okay? Why I'm doing this? So basically this side is now equal to this side. This I have shown. So that means now if I take this triangle, so if these two sides are equal, so that means this angle will be equal to this angle, right? I give it some name 1 and 2. So I can say that in triangle, this PBQ, right? So now what do I have? So I have PB is equal to BQ, and therefore we can say that angle 1 is equal to angle 2. So we will use this result later. You can call it your equation number 3. And yeah, please write the reason also, that angles opposite to equal sides are equal. Right? So basically we are trying to show that angle, this angle, this one is 90 degree. Okay. Now I'm thinking of these two angles. Now see carefully. At least angle 1 is equal to angle 2 I have got, right? Now I mark this angle as angle 3 and this angle as angle 4. So let us try to show that angle 3 is equal to angle 4. Right, Jocelyn? Now how can I do it? If I show that this triangle and this triangle are congruent. So by CPCT, I can say that angle 3 is equal to angle 4, right? So let us try to show them congruent. If I take in triangle APS and triangle this CQR, right? So now what do we have? So first of all, see the outside is a it's a rhombus. So now see here, sides of a rhombus are equal, right? Okay, now think of it like this. If I say that AP, like this side, is equal to this side. Why? Now see the reason here. Because the full side AB is equal to BC, right? So that implies half of AC is equal to half of BC, right? And that implies the half of AB is AP and half of BC is CQ. So from here we can say that AP is equal to CQ. So in this triangle, this side I have got equal to this side. Similarly, I can show this side is equal to this side. Again, so I'm saying that AS is equal to CR. Reason, same reason, that AD is equal to CD, right? So that implies half of AD is equal to half of CD. That means AS is equal to CR. Is this understood, Jaslyn?
Yes, ma'am.
Okay. Now one more side I need. Now, because I've already shown that PQRS is a parallelogram, right? The inside one, the inside quadrilateral. So that means opposite sides of a parallelogram are equal. So I can say PS is equal to QR, right? Opposite sides of a parallelogram are equal. So I have also got this side is equal to this side. So basically by SSS criteria, now these two triangles are congruent. So by SSS, we can say that triangle APS is congruent to triangle CQR. And therefore, by CPCT, we can get angle 3 is equal to angle 4, which we were actually trying to show. So you can mark it as result number 4. So ultimately, result number 3 and result number 4 we will be using later, right? So all this effort was to show that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So at least this much we have done. Okay. Right, Jocelyn. Now one more thing we do here is, now let us give this one some name, right? So I'm calling now this angle 5 and this angle 6. Is that clear? Okay. Now look at the figure very carefully. The inside quadrilateral, which is PQRS. So we have already shown that it is a parallelogram, right, Jocelyn? So there's a theorem that the consecutive angles or the adjacent angles of a parallelogram are supplementary, right? So we can say that angle 5 plus angle 6 is equal to 180 degree, right? I hope you are getting it.
Yes, ma'am.
Okay. So now since PQRS is a parallelogram, right? Already we have proved it. So we can say that angle 5 plus angle 6. Yeah, this much at least we can say here. Mm, yeah, okay. So this is equal to 180 degree. Why we can say? First of all, give it some name. Let's say equation number 5. So you can write that adjacent angles of a parallelogram are supplementary. Okay. Mm, I think we can do this line later. Just 1 minute. Before this, let us try to show one thing. Then we will use this result. Okay, now look at the figure again, Jaslyn. Now, because AB is a line, right? So can I say that angle 1 plus angle 5 plus angle 3 is 180 degree? Right? I mean, it's a line. That means this complete angle is 180 degree. So angle 1 plus angle 5 plus angle 3 is 180 degree, right? You can write like this. Now AB is a line. So I'm saying that angle 3 plus angle 5 plus angle 1 is 180 degree. Why? Because linear pair, right? You know this, linear pair. Mm, okay, give it some name. And similarly, we can say also the other one, BC is also a line, right? In the figure. So similarly, I can say that angle 2 plus angle 6 plus angle 4 is also 180 degree. Again, linear pair. So also BC is a line. So now I'm saying that angle 2 plus angle 6 plus angle 4 is 180 degree. Again, linear pair. Is that okay, Jocelyn? Right. Now, I have already shown that here, basically now I want to change these two angles. So this angle I want to change and this angle I want to change. I've already shown in result number 3 that angle 2 is equal to angle 1, right? So in place of 2, I can write angle 1 plus angle 6 plus, and here in result number 4, this is equal to angle 3. Is that okay? So now you can call it 6. Now if you compare 5 and 6, can you compare 5 and 6?
Yeah.
Yeah, yeah. Now see here, this and this. So the right hand side is 180 degree, right? Both. So that means their left hand side is also equal. So that means angle 3 plus angle 5 plus angle 1 is equal to angle 1 plus angle 6 plus angle 3. Now we have angle 3 both sides, then angle 1 both sides. So this gives us that angle 5 is equal to angle 6. So at least we have got this, right? Okay. Now they are equal. Okay, and now we can use that theorem of a parallelogram. So we have got them equal. Now also we can say that PQRS is a parallelogram. We have already proved this. And then we can say that angle 5 plus angle 6 is 180 degree. What is the reason? Adjacent angles of a parallelogram are equal. Sorry, are supplementary. Right, Jaslyn? Now we will use it here. So angle 5 plus angle 6 is 180 degree, and also they are equal. So we can say angle 5 plus angle 5 is equal to 180 degree. Why? From 7th we have used, right? So and that means twice of angle 5 is 180 degree, right? And that implies that angle 5 is 90 degree. Is that correct? So therefore, now one of the corner angle we have got 90 degree. So we can say that PQRS is a, or you can give it some name if you want, that angle. mm, what is the name of this angle? 5 SPQ, or angle SPQ is equal to 90 degree if you wish. So PQRS is a parallelogram with one angle 90. Right, so we have proved two things. In the first step, we have proved it's a parallelogram. In the second step, we have shown that one angle is 90 degree, and therefore we can say it is a rectangle. So therefore PQRS is a rectangle. Yeah, any question, Jocelyn? Okay. So it was a long question, no doubt. And like many theorems were used in this question. Theorems of lines and angles also, the properties of, congruent triangles also, isosceles triangle also, properties of a parallel lines, and many theorems were used. Properties of parallelogram. But it was an interesting question, right? Okay, so if you have written, we can move to the next question now. All right, so now ABCD is a rectangle. Okay, so this time it is a rectangle which is given to you. Right, ABCD. And PQRS are the midpoints. Okay, so the midpoint is PQRS. Okay, respectively. Show that the quadrilateral PQRS is a rhombus. So now if you join it, good, you have to show it's a rhombus. So this time it is given that ABCD is a rectangle, right? And to show that PQRS is a rhombus. So rhombus means, again, the first step you have to show it's a parallelogram. Second step, that all the sides are equal. Clear? Okay, so again we do one construction here. We join this AC. So construction is join AC. Oh, let us prove. So again, you can first of all define what is a rhombus so that you remember exactly what you have to do. So a rhombus is a parallelogram with all sides equal, right? So here basically the first step is to show that PQRS is a parallelogram, and the second step is to show that all the sides are equal, right? So again, I do it in a similar manner. Like I take first in triangle ABC, right? And here I take triangle ADC. So I divide this into two triangles and I'll apply midpoint theorem again. So if I apply midpoint theorem, so very easily I can show that this side is equal to this side, as we have done in the previous question. So that part will be same here. So P is the midpoint of AB and Q is the midpoint of BC. So from midpoint theorem, your PQ will be parallel to AC and PQ will be half of AC. So that's your result number 1. You can name it. Similarly here, you will say that S is the midpoint of AD. So R is the midpoint of CD. So again, we can say SR is parallel to AC and SR is half of AC. So this is also from midpoint theorem. So this much part is similar as previous question. So at least I have got one side. Yeah, so now if I combine 1 and 2, so from 1 and 2, what will I get? This is also parallel to AC, this is also parallel to AC. So I'll get PQ will be parallel to SR, right? And also PQ will be equal to SR because both are half AC, half AC. So again, one pair of opposite side is equal and parallel, so it's a parallelogram. Understand? So one pair of opposite sides is parallel and equal. So therefore, PQRS is a parallelogram. So up till here, it's just a repetition. Now we have to show all sides are equal. So this is easy, Jaslyn. Now we have already shown opposite side equal, right? So at least now see here, like one pair of opposite side, here we have already shown equal. Now because it is a parallelogram, so the other pair will also be equal, right? Now because it's already a parallelogram, so therefore the other pair, that means PS will be equal to QR. Why? Opposite sides of a parallelogram are equal, right? So this side is equal to this side. So opposites are equal. Now we have to establish a relationship to show that, adjacent sides are also equal. Like we have to combine these two results. Understand? So for that, we can do one thing. If I take like this triangle, right? And I take this triangle. Now why I'm taking it? Because its one side is PS and its one side is PQ. So if I show these two triangles congruent, and by CPCT I'll say that PS is equal to QR. So ultimately in the parallelogram my adjacent sides will be equal. Is that clear? Okay, so let us do it here. Or I can draw it again if you can. So let us show these two triangles congruent, right? So in triangle uh, APS and triangle this B sorry BPQ, right? Hmm. So same, I can say that AP is equal to BP. Why? Because P is the midpoint of AB, right?
Yes, ma'am.
Okay. And what else I can say? Yeah, okay. So I can say that this angle is equal to 90 and this also equal to 90. Why? Because ABCD is a rectangle already given, right? So angle, uh, you can call it 1 and 2 if you wish. So angle 1 is equal to angle 2. Why? Uh, ABCD is a rectangle already given. Okay. Then, yeah, again I can say PS is equal to, no, this I have to show, sorry. So I cannot say. What else I can say here? Yeah, so this side I can show, right? This and this. Why? Because already the full side AD is equal to BC because it's a rectangle, right? So the half of AD will be half of BC. I can say that AS is equal to PQ, right? Now why I'm saying it? The full side AD is equal to BC. The opposite sides of a rectangle are equal, right? So if I divide half, so half of AD is equal to half of BC. Now what is half of AD? That is AS, and half of BD, because S and Q are already midpoint. So therefore I can say half of AD is AS, half of BC will be PQ. So that is why I'm saying it. So this becomes SAS criteria, right? So by SAS, triangle APS is congruent to triangle BPQ. And therefore by CPCT we can say this side PS is equal to PQ, which I wanted to show, right? So now I've got this side equal to this side, not the opposite one, but the adjacent one. You can give it some name. So yeah, actually these are important results. So give them some name here. So we are going to use this market 3 and also this market 4, right? So in the side, I'm just writing because you're not able to see that. So 3 is PQ is equal to SR. Okay, and the fourth is PS is equal to QR. So already we have proved it, right? And now from CPCT, I've got this. So market 5. Okay, so now you combine 3, 4, and 5. So from 3, 4, and 5. Okay. So any equation you can write first. Write from 5. So PS is equal to PQ, right? Now what is PQ equal to? So from 3, PQ is equal to SR, right? And so from 4th, PS is equal to QR. So this is equal to QR. So this way you can combine 3, 4, and 5. or so QR, then so in a sequence, if you want, you can write it, or you can say that PQ is equal to QR is equal to uh, RS is equal to PS. So you can write in a sequence. That's it. So now what is happening? So thus, we can say now, we can conclude that PQRS is a parallelogram. We have already shown with all sides equal. So we are getting these two results. Now what is this figure called? It's called a rhombus. So therefore, PQRS is a rhombus. Okay, written, Jocelyn.
Yes, ma'am.
So fourth question I've already done. Let us do the fifth one now. Now in a parallelogram ABCD, so write down given thing. ABCD is a parallelogram. E and F are the midpoints. So you have to write E is the midpoint of AB and F is the midpoint of CD. So can you see that? E and F? Okay. So show that the line segment AF and EC trisect the diagonal BD. So trisect means it is dividing it into three equal parts. So you have to show that this part is equal to this part is equal to this part, right? Okay, so it's a good question. I mean, it can come in exam and not very difficult. So you have to show basically that PQ is equal to QP is equal to DP. Understand? So one by one, let us take it. Mm. Now, because ABCD is a parallelogram. Now see here, ABCD is a parallelogram. This is given to us. So that means the opposite sides are parallel. So therefore, I can say that AB is parallel to CD, right? AB is parallel to CD. Is that okay? Why? Opposite sides of a parallelogram are obviously parallel. That is why it's a parallelogram, right? Okay. And now because the complete side AB is parallel to CD, so that means some part of AB will be parallel to some part of CD. Clear? So from here I can say, because I'm interested in this part and this part. Why? Because I'm trying to show that AEFC is a parallelogram. That clear? Right, Jocelyn? So basically, I'm trying to show that this much is a parallelogram. So I want to show that A is parallel to FC first of all. So from here I can conclude. Now AB is parallel to CD. So I can say that AE will be parallel to CF. Why? So you can write that parts of parallel line are also parallel. Obviously, you're just cutting the line. That's it. Okay. And also I can say that AB is equal to CD because opposite sides of a parallelogram are equal. This I can say, right? So I divide this again. Half of AB is equal to half of CD. Now what is half of AB? That is AE. Why I can say? Because E is the midpoint, right? Already given. So I can say AE is equal to CF. Why? Because E is the midpoint of AB and F is the midpoint of CD. This was already given to us. Given. Understand? So now what is happening here in this figure? One pair of opposite side, I mean this side, I have got equal, right? And also I have got parallel. If you combine this and you combine this, right? Right. So if I consider this quadrilateral, so that means in quadrilateral A, E, C, F. Now what is happening? So I'm getting AE parallel to CF and I'm getting AE is equal to CF. So that means I can say that one pair of opposite sides is equal and parallel. So one pair is equal and parallel, and therefore I can say that uh, the quadrilateral AECF is a parallelogram. Is that understood, Jocelyn? So far? Yes, Jocelyn. So far, is it clear?
Clear.
Okay. Now, because I've already shown that it's a parallelogram, so the other pair, which I'm not considering here, so the other pair will also be equal and parallel, right? Because we have already proved now it's a parallelogram. So now it will also imply that the other pair, that means AF will now be parallel to CE, right? Why? Opposite, or you can say ABCD. Okay, don't say anything because we have just written that it's a parallelogram. So we are implying it. That's it. Okay. Mm, now what I can say now, because the complete side AF is parallel to CE, so its part, that means AF part will be PF, right? Will be parallel to CQ. Can I say that? Right? I mean, I'm considering this part is parallel to this part because the full line is parallel, so the certain part of it will also be parallel. Is that clear? And also the other part will be parallel. The remaining part AP will be parallel to CQ. You can write in bracket that parts of parallel lines are parallel. Is that clear? So now this part is parallel to this part. So this much we have got in this figure. Now I can easily use midpoint theorem. Why I'm doing this? Now you consider for midpoint theorem we need triangle. Remember? Right? Midpoint theorem can be applied in a triangle. So now you consider, okay, I'm writing here. In triangle DQC. Can you see that in the figure? DQC. This triangle I'm taking. Right, Jocelyn? DQC. Okay. So the converse of midpoint theorem I can use here because I've already shown that PF is parallel to CQ if you see here. So PF line is parallel to CQ. I have already shown, right? And it is given that F is the midpoint of CD. This is given. So by converse of midpoint theorem, now what can I say by converse? So by converse, I can say that P is the midpoint of DQ. Remember, Jocelyn? So now because P is the midpoint, so that implies that uh, I can say that DP is equal to PQ. Now you can call it some result number, or one you can say, right? And the same thing now I will be doing in this triangle. Now I'll consider this triangle. Okay. Now in this triangle, I have already shown EQ uh, is parallel to AP. AP is parallel to EQ. Mm. Oh, I have done a little mistake here. Here, see again here. Okay, I'm just erasing it a little bit. The figure is very messed up. Now see here, Jocelyn, again. The full side AF was parallel to CE. Is that clear? See in the figure, AF is parallel to CE, right? I mean, this complete side is parallel to this complete side, right? So their parts are also parallel. So that means this uh, so PF has to be parallel to CQ. Okay, that I have written correct. And then AP has to be parallel to EQ. Sorry, not CQ. Please correct it. Can you see that in the figure? So basically, I'm saying if I use a different pen, so I'm saying that this part will be parallel to this part and then this part will be parallel to this part. Is that clear, Jaslyn? I hope it's clear now. All right. So in one triangle, DQC, I have already used converse of midpoint theorem, and that has given me that P is the midpoint of DQ. So that implies that this side is equal to this side. Is that understood? Right. Now I will be taking this triangle ABP, right? See that in the figure? ABP. Now in this triangle, I already have this side EQ is parallel to AP, right? Here. And E is the midpoint of AB, which is given to me. So again, by converse of PPT, I can say that Q is the midpoint of PP. All right. So this much I'm going to write now. So in triangle ABP, right? So first of all, write that E is the midpoint of AB. And then this line, what is the name of the line? EQ is parallel to AP. We have proved it, right? So again, by converse of PPT, I have got, so it will be that Q is the midpoint of BP, right? Now because Q is the midpoint, so I can say that PQ is equal to BQ. So it implies that PQ is equal to BQ or QB. So you mark it as result number 2. Now you combine result 1 and 2. So how do you combine? First of all, write 1. So DP is equal to PQ, right? And from 2, your PQ is equal to QB. So you can write QB. Now look in the figure again. So DP is equal to PQ is equal to QB. So we have got the 3 parts equal. So therefore we can say, hence, the line segment um, the 2 line segments, what were they? AF and EC. Okay, so the line segment AF and EC trisect the diagonal BD. Okay, so 2 questions are remaining, Jocelyn, in this chapter. So this chapter will be over. And if you have any upcoming exam or any test, Jocelyn, so please tell me a little bit in advance and send me the name of the chapters which are coming so I can take accordingly. But anyway, I will be starting a new chapter now. So let's see which one I'll start. Okay. Okay, just 1 minute. Let me recall. So how many chapters we have already done, Jaslyn? If I 1 minute. Just 1 minute, Jocelyn. Let me just discuss. Okay, so you can keep write. You can write yes or no. Okay, for the answer if you're not able to speak up. So number system we have already done, right? Let us just recall a little bit. Can you speak up, Jocelyn? Jocelyn, can you hear me? Please unmute yourself.
Ma'am, can you hear?
Yeah, so Jocelyn, number system we have done, right?
Yes, ma'am.
Okay, then polynomials.
Yes.
Then we have done coordinate geometry, right?
Yes.
Okay, linear equations.
Yes.
Yes, we have done. I think the next one, yeah, in Euclid's geometry, I have not done, right?
Yes, ma'am. You have done.
I have no, I think in my class I have not done. You must have done in the school. Yeah, I have not done this so far. Anyway, so six lines and angles I have done, right? And then triangle is also over. Now the quadrilateral is over. Then areas of parallelogram and triangle is remaining. Okay. Then after that, okay, circles we have not done, right?
Yes, ma'am.
So ninth and 10th are remaining. Okay. Then construction, I think it's out of syllabus. Let me just check. Okay. 12th, we have Heron's formula. I think that we have done, right? Heron's formula earlier we did.
Yes, ma'am.
Okay. Surface area and volume we have not done. Okay. Statistics we have already done.
Yes.
And probability is remaining, I think. Yeah.
Yes, ma'am.
Yes, it's remaining. So anyway, 5 chapters from my side are remaining in your syllabus. So hopefully we will do it. No, not 5, 6, including Euclid's geometry. 1, 2, 3, 4, 5, 6. Yeah. All right then. Okay. Thank you.
Okay, bye,